In this question, we're asked if the set of vectors given here is linearly independent. There are lots of different ways to figure this out. One way is to put them in a matrix. The first way is a matrix where the columns are these vectors, and then we row reduce that and we try to see if the number of pivot columns is equal to the number of vectors. Second thing you could do, which is what we're going to do here, is we're going to look at the determinant and we want to see if that's 0 or not. And of course, the other way, using the definition, you look at CV1 plus CV2 plus CV3, set that equal to 0, and see if the only solution is C1 equals C2 equals C3 equals 0. Okay, the determinant way though. So let's start with our 1, 2, 3, 3, 5, 7, 0, 1, 2. And then we're going to put our first two columns again, 1, 2, 3, 3, 5, 7. And then we start looking at our different combinations. So we've got this one, plus this one, plus this one. So 1 times 5 times 2 plus 3 times 1 times 3 plus 0 minus, we look at these combinations. So 3 times 2 times 2 minus 1 times 1 times 7 minus 0. So 1 plus 5 plus 2 is 10, plus 9 plus 0 minus 3 times 2 times 2 is 12, minus 7 minus 0. 12 and 7 is 19, 10 and 9 is 19, so this actually is equal to 0, which means these vectors are linearly dependent. And if we just take a look at the vectors, if we want to get a 0 in this top right corner, we'd need to take 3 of vector 1, subtract 1 of vector 2. So if we look at 3v1 minus v2, this is going to give us 3 times 1 is 3, minus 3 is 0. 2 times 3 is 6, minus 5 is 1. And 3 times 3 is 9, minus 7 is 2. So in fact, this is the combination of the first two vectors that gives you the third vector.